Dear learners, Assalamu alaikum. I wholeheartedly invite all of you to watch the video. Introduction. Our today's topic is concept of probability and probability tree, part 2. Learning outcomes. At the end of this class, the learners will be able to explain the concept of probability and describe the probability tree. Probability. It is an estimate of confidence which may be occurred in an event measured on a scale from 0 to 1. Mathematically, if a random experiment can result in any exhaustive, mutually exclusive, and equally likely outcomes, and aim of these outcomes are favorable to an event A, then the probability of the event A, denoted by P of A, is defined as P of A is equal to N of A by N of S is equal to M by N. In brief, probability of an event is equal to number of favorable outcomes by number of all possible outcomes. We will frequently use this formula in solving problems related to probability. Important board question. So that the probability of an event in a random experiment is from 0 to 1. The solution of this question will be made complete by applying the mathematical definition of probability. Solution. If an experiment results in n exhaustive, mutually exclusive, and equally likely outcomes, and m of these outcomes are favorable to an event A, then clearly 0 less than equal to m less than equal to n. A question may be arisen in you, how can this may be written? Let us explain. N is the number of elements in the sample space and m is the number of elements in the event A. The lowest event of a sample space is an impossible event. The number of elements of an impossible event is 0. The event A may be at least equal to an impossible event and at most equal to a sample space. That's why m can never be less than 0 and greater than n. It means m will be from 0 to n. This implies that 0 by n less than equal to m by n less than equal to n by n, dividing each side by n. This implies that 0 less than equal to m by n less than equal to 1. But by definition, P of A is equal to m by n. Therefore, 0 less than equal to P of A less than equal to 1. Therefore, probability of an event in a random experiment is from 0 to 1. Explanation. Let us toss an unbiased coin twice. Then the sample space of this experiment is S is equal to set of A's, ST, TA's, TT. It has 2 to the power 4 or 16 events because we know that every set having n elements has exactly 2 to the power n subsets. Of them, let us consider the 4 events. E1 is equal to pi, E2 is equal to set of ST, TAs, E3 is equal to set of SAs, ST, TAs, and E4 is equal to set of SAs, ST, TAs, TT. E1 is an impossible event. E2 and E3 are both proper events. E4 is a sure or certain event as E4 is equal to S. Here sample space S is equal to set of S's, ST, TAs, TT. Therefore, number of all possible outcomes is equal to 4. In case of E1 is equal to 5, number of favorable outcomes is equal to 0. Therefore, probability of the event E1 is equal to number of favorable outcomes by number of all possible outcomes is equal to 0 by 4 is equal to 0. E1 is an impossible event. We have already mentioned it, and so probability of impossible event is 0. And as well, the probability of an event can never be less than 0. In case of E2 is equal to set of HT, TH, number of favorable outcomes is equal to 2. Therefore, probability of the event E2 is equal to number of favorable outcomes by number of all possible outcomes is equal to 2 by 4. 2 is a common factor between 2 and 4. That's why we can write 1 instead of 2 and 2 instead of 4 is equal to half. In the event E2, there are two outcomes, HT and TH. Number of A's in both outcomes is 1. It is the least number of times in the throw of a coin twice. Also, the number of T in both outcomes is 1, which is the least number of times in the throw of a coin twice. Both outcomes are of exactly 1 A's and of exactly 1 T in the throw of a coin twice. That's why this is the probability of 1 getting A's the least number of times in the throw of a coin twice, 2 getting T the least number of times in the throw of a coin twice, 3 getting exactly 1 A's in the throw of a coin twice, 4 getting exactly 1 T in the throw of a coin twice. In case of E3 is equal to set of ACH, HT, TH. Number of favorable outcomes is equal to 3. Therefore, probability of the event E3 is equal to number of favorable outcomes by number of all possible outcomes is equal to 3 by 4 is equal to 0.75. This is the probability of getting at least 1 A's in the throw of a coin twice. It is also the probability of getting at most 1 T in the throw of a coin twice. Dear learners, it is very much important to remark that in case of at least 1 A's, you should exclude the outcomes having no H. And in case of at most 1 T, you should exclude the outcomes containing more than 1 T. However, in case of E4, set of ACs, HT, TH, TT, number of favorable outcomes is equal to 4. Therefore, probability of the event E4 is equal to number of favorable outcomes by number of all possible outcomes is equal to 4 by 4 is equal to 1. E4 is a sure event, we have already mentioned, and so probability of sure event is 1, and as well the probability of an event can never be greater than 1. Thus we can say that the probability of an event is always from 0 to 1. Probability tree. Probability tree is a diagram in the shape of tree which is used in the formation of sample space and to find the probability of various events. Some examples of probability tree are given below. 1. Probability tree of tossing a coin twice or of tossing two coins together. For the first coin, we should draw a diagram with two hands, Ace hand and T hand, For the ace hand, we draw a diagram with two hands for the second coin. And for the T hand, we should draw another diagram with two hands for the second coin. It means if the outcome of the first coin is ace, then the outcomes of the second coin may be of ace or T. If the outcome of the first coin is T, then the outcomes of second coin may be of ace or T. However, thus we get the sample points ace, 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 T, T, ace, T, T. From this tree diagram, we can easily write the sample space. Ace is equal to set of ace, 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 T, T, ace, T, T. 2. Probability tree of tossing an unbiased coin thrice or of tossing three coins together. In the same way, we should draw this probability tree. At first, we should draw a diagram with two hands, ace hand and T hand, for the first coin. And then for each hand, we should draw diagrams with two hands for the second coin. And then for each hand, we should draw the diagrams with two hands for the third coin. Thus, we get the outcomes ace, 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 T, ace, T, H, ace, T, 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 ace, ace, T, ace, T, 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 H, T, T, T. From this diagram, we can easily write the sample space S is equal to set of ace, 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 T, ace, T, ace, ace, T, 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 ace, ace, T, ace, T, 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 ace, T, T, T. 3. Probability tree of tossing a dice and a coin together. We should draw a diagram with 6 hands for the dice. For each hand, we should draw diagrams with 2 hands for the coin. Thus, we get the outcomes 1 ace, 1 T, 2 ace, 2 T, 3 ace, 3 T, 4 ace, 4 T, 5 ace, 5 T, 6 ace, 6 T. From this diagram, we can easily write the sample space. S is equal to set of 1 ace, 1 T, 2 ace, 2 T, 3 ace, 3 T, 4 ace, 4 T, 5 ace, 5 T, 6 ace, 6 T. 4. Probability of tossing a dice and 2 coins together. For the dice, we should draw a diagram with 6 hands. And then for each of the 6 hands, we draw diagrams with 2 hands for one of the 2 coins. And then for each hand, we draw diagrams with 2 hands for the remaining coin. and thus we get the sample space S is equal to set of 1 SS, 1 ST, 1 TS, 1 TT, 2 SS, 2 ST, 2 TS, 2 TT, 3 SS, 3 ST, 3 TS, 3 TT, 4 SS, 4 ST, 4 TS, 4 TT, 5 SS, 5 ST, 5 TS, 5 TT, 6 SS, 6 ST, 6 TS, 6 TT. Database probability. The probability derived from past experience or data is called database or a posteriori probability. As for example, if it rained on 21 days out of the 31 days in the month of July last year, then the probability on a particular day of the same month this year is 21 by 31. If you have any query after watching the video, please let me know. The answer of your question will be given very quickly with utmost sincerity. With this, I conclude here. Thanks. Best of luck.